Welcome, my friends. In this video, I'll be discussing section 3.5, histograms. First, we must discuss the frequency distribution. A frequency distribution splits data into classes and shows how many data values fall into each class. A frequency distribution is created for quantitative data. The easiest way to show you what a frequency distribution is just to give you an example. Let's consider the variable of commute distance in miles for individuals working in Grand Rapids. We need to split our data into what are called classes, which are really just groups of numbers. So the first class contains the numbers 0 through 4, representing a commute distance from 0 to 4 miles. We have 32 individuals who are commuting this distance, which represents 7.1% of the total individuals. Note that you can calculate the relative frequency by simply taking each frequency and dividing by the total of all the frequencies. So if you took 32 and divided by the sum of all the frequencies, you should get about 0.071, which in percent form is 7.1%. Note that the classes should all be of equal length. So from 0 to 4, to 4 to 8, 8 to 12, each of these contain the same number of miles. Sometimes the last class will be an exception, which in this case is just greater than 28. As I already mentioned, you can find the relative frequency column by taking the frequency and dividing by the total of all the frequencies. Now, one more thing to mention is it appears like we might be double counting some of the values, as we see 4 twice, 8 twice, 12 twice, etc. But usually the convention is you will only include the value the first time it appears. So if someone had to commute 4 miles to get to their job in Grand Rapids, the first time the 4 appears is in the very first class, so we would count that in the first class. Or if someone was commuting 16 miles, well, the first time 16 appears is in this class from 12 to 16, so we would include the individual there. A histogram is going to graphically display a frequency distribution. Each class is going to turn into a bar, and the length of each bar is going to be the corresponding frequency. So looking back at our frequency distribution, now each class, 0 to 4, 4 to 8, etc., is going to be represented by a bar on our histogram. And the length of the bar is going to be represented by the frequency, or we could also use the relative frequency. Now, a histogram is not synonymous with a bar graph or bar chart. A histogram is a very specific type of graph, where the horizontal axis will always have a quantitative variable, or you could say classes of or groups of a quantitative variable, and the vertical axis will always be something that represents either frequency or relative frequency. If you don't have those two things, then you don't have a histogram. Note that unlike a bar chart, in a histogram there should not be gaps between the bars, and that's to represent the continuous nature of our number system. With a bar chart, we typically had a categorical variable, and each bar was represented by a separate category. So typically that meant we were going to have some gap between each of the bars, but that's not the case with a histogram. Okay, we've discussed the distribution of a variable before, but now let's discuss how to describe the distribution of a variable based on a histogram. The distribution of a variable is going to describe the possible values of the variable and how likely each value is to occur. You may remember that there are 4 different things we should discuss whenever we are describing the distribution of a variable. For a histogram, that means that we must first describe the center of the distribution by approximating the median. It's a little bit more difficult to approximate the median in a histogram than a box plot, but it still can be done, which we'll do on a future slide. Second, we must describe the variability of the distribution. Now, we can't really tell the standard deviation or IQR or any of those measurements just based on the histogram, but we can still assess the variability based on how clustered or spread out the bars are. The main strength of a histogram is that it easily allows us to describe the shape of the distribution. This can simply be assessed by the shape of the histogram. Remember, this would be labeling the distribution as something like skewed left, skewed right, normal, bimodal, uniform, or any of those terms. We can also identify the outliers of the distribution by finding bars that are a little bit disconnected from the rest of the data. We'll look at examples of how to describe the distribution based on these 4 criteria in a future slide. First, let's focus a little bit more on the shape of the distribution and how we can tell that based on a histogram. The shape of the histogram can tell us about the distribution of the dataset, the possible values of the variable, and how likely they are to occur. There are 5 common distribution shapes that you should be familiar with. I'm going to be using the variable example of test scores to describe each of these different distribution shapes, because depending on the class, test scores could follow any of these different distribution shapes. First, we have the normal distribution. Before we talk about this, just note that for every single one of these distributions, the vertical axis is representing frequency, and the horizontal axis is our quantitative variable. For our variable of test scores, that means as we move towards the right, we are representing larger test scores, and as we move towards the left, we are representing lower test scores. For a normal distribution, the highest bar is right in the middle, so that means that the median test score will be the most common. Let's say 75. As we move towards larger test scores, they're going to be less and less common. So it's not as common for someone to get a 90 as maybe a 75. The same is true as you move towards the left. A value of, let's say, 60 is a lot less likely than 75. So this is what we call a normal distribution, where most of the data is in the center, with less and less data falling towards the tails of the distribution. Next, we have the uniform distribution. For a uniform distribution, all data values have approximately the same frequency. So this would be like saying we have just as many people scoring a 50, as a 60, as a 70, as an 80, as a 90, as a 100. We have just as many students that are getting each of the possible values of the grade for this test. Next, we have bimodal, which is where there are 2 peaks to the distribution. So this would be where you have a number of students who are not scoring very well on the test, a number of students who are scoring quite well on the test, and maybe not as many in the middle. Then we have these skewed distributions. A skewed left distribution has a left tail. We have more larger values of the variable and less smaller values. So this would be where you have a lot of students who are scoring very high in the test, and not as many students who are scoring lower. And the skewed right would be just the opposite. So now we have a lot of lower values of our variable and not as many large values. So this would be a lot of students scoring quite poorly and not as many students scoring quite as well on the test. The way that I remember skewed left and skewed right is the directionality in which the distribution diminishes. So as we move toward the left, the skewed left distribution diminishes or tails off. And as we move towards the right, in a skewed right distribution, the distribution diminishes or tails off. So make sure you are familiar with these 5 different distribution shapes. All right, here's an example of a histogram. So let's go ahead and describe the distribution of this histogram by using those 4 different criteria. First, we would like to describe the center of the distribution, which can be found by locating the median. Now that's easier said than done, because the median is not really popping out at you on the histogram. The best way to find the median is to first figure out the total number of values there are, and then from there try to determine which bar contains the median. So the way I'm going to do this is I'm going to basically estimate how many values there are in each of these bars, or basically what the frequency is for each of these bars. So it looks like over here between maybe 0 to 10, there's like 1 value. So I'm just going to put 1 here. Between 40 and 50, it's looking pretty low, like maybe around 3. And we don't have to be perfect here, we're just kind of estimating. Between 50 and 60, looks like we maybe have, I don't know, maybe it's about twice as high as this one, so maybe 6. Between 60 and 70, let's see, that looks like it's just about 20 or maybe just below 20. Maybe I'll do 18. Just kind of estimating here. Between 70 and 80, let's see, what is this looking like? It's looking pretty close to right between 20 and 40, so maybe this is 30. What about between 80 and 90? And this is looking like it's just below 60, I think. So maybe like 50, 57. And then finally, the last one looks like it's pretty darn close to 80. Okay, so just kind of estimating how many values there are in each of these classes, right? And now I'm going to grab my calculator and I'm going to add all those together. So here's my calculator. I'm going to take 1. Let's get this going here. I think my numlock's off. There we go. 1 plus 3 plus 6 plus 18 plus 30 plus 57 plus 80. and it looks like I get 195. Now, something that you might not know about the median is you can find the position of the median, which is basically which ordered number the median is, by taking your sample size, adding 1, and then dividing by 2. So that basically what that's telling me is that the median is the 98th value. So if I counted and figured out which bar contains the 98th ordered value, then that's going to tell me approximately where the median is. So the way I'm going to do this is I'm going to start adding these values up until I can figure out exactly where the 98th value is. So I'll show you how I can do that. So I know it's not going to be in the first few bars. It's probably going to be either this bar or this bar. It's looking like it's probably between 80 and 90, but I'm not quite sure yet. So if I start adding up some of these values, if I just add up these values, I added up 1, 3, 6, and 18. I get 28. That's not high enough. I'm trying to find 98. So let's keep going. If I add to that 30, I'm at 58. I'm still not at 98. I'm trying to get to 98. Now I can see that if I take the 58 that I have so far and I add 57, now I'm going to be past 98. So when I was in this bar, I was only up to 58 of the observations. I'm trying to find the 98th observation. Where is the 98th observation? Because that's going to be my median. And I just found out that it's somewhere between 80 and 90. Because before I added this 57, I was at 58, and after that, I've got to 115. So that means that 98 was somewhere in there. The 98th observation is somewhere in this bar here. Now, I don't know exactly what that value is. I can just kind of estimate it's somewhere between 80 and 90. So all that together is to say that the median is somewhere between 80 and 90. Okay, so I know that's a little bit tedious, but that is the way that you need to find the median based on a histogram. You can sometimes just kind of guess or estimate, and you might be right, but really the way you should be doing this is adding up all the frequencies and figuring out which bar contains, in this case, the 98th value. All right, continuing from there, we can also kind of describe the variability of the distribution. We can't find the IQR, we can't find the standard deviation just based on the histogram, but we can say that the histogram is kind of telling us, well, the data is relatively spread out. It's not all just right around one number. We have numbers as high as close to 100 all the way down to 0. So we could just say that the data set is fairly spread out. There's a fair amount of variability in this distribution. We can also talk about the shape of the distribution. So we can easily see here that this has a tail towards the left. And this is what we call a skewed left distribution. Finally, we can describe the outliers of the distribution. In this case, there is one outlier. It's this value somewhere between 0 and 10. So we have one outlier in this distribution. So that's how you should describe the distribution based on a histogram. You should do these 4 things in kind of the same manner that I have done them in here. So here is a problem for you to try. So this histogram shows the number of licks reported to reach the center of a Tootsie Pop from a sample of 70 volunteer lickers. So we have all of these different kind of possible numbers here. I think this last one's supposed to be 1200. It's a little bit cut off here. But here's the histogram, and see if you can figure out all 4 of these things. Describe the center of the distribution by estimating the median, the variability based on how spread out the bars are, the shape based on the shape of the histogram, and finally see if you think there are any outliers based on the histogram. So I'll let you give that a try. Go ahead and pause the video. And that's all I have to talk about histograms in this video, so I will see you in the next one.